Hi everyone, welcome back. Hopefully you've had a chance to play around with your model now, and it's always fun playing with the model you've created. So hopefully you've had a bit of fun doing that. Um, One thing to note, and you may have found this already, um, because we're using servers, we open a port for that server. If you then close down your server, your browser window, and then run the code again, you may well get an error saying that the port isn't free or whatever. What you'll actually need to do at the moment is to restart the kernel to close down the server, flush it out, and then start again. And you can do that in your IPython console, shown on the screen here. If you click the little cog button, I'll just show you on Spider itself. So up here, we click the cog button, and then you can click restart kernel. Click that, it'll come up with a prompt, just select yes, and that will then restart the kernel, clear everything out, all the variables, etc., that you've done, the server ports, etc. Okay, so we're now going to talk about data collectors. So you probably remember at the very start, when we first started writing our disease model file, we imported something called a data collector, and I said we'll talk more about that later. Well, now we're going to use it. So it would be really useful in our model if we could collect data throughout it, so that we could collect together results or display the outputs on a graph of how things are happening over time, and that would be really useful for us. And we can do this in MESA really easily using these things called data collectors. So let's set up a data collector that's going to monitor the total number of infected agents over time, because that might be really useful information for us. So the first thing we're going to need to do is to write a function that calculates the result we want to collect, in this case the total number of agents infected at each time step of the model. I'm going to write that in the disease model file. So in your disease model.py file, we're going to insert this function at the end after our person, agent, and disease model class definitions. So this is the function we're going to write, and again I'm going to talk you through this before getting you to write this out. So I've called the function calculate number infected. The input to the function is going to be the model. The first thing I'm going to do is set up a counter. I'm going to start that counter with the default value of 0, and this counter is going to keep track of how many are infected at this time step. So the next thing we're going to do is use what you may remember from an earlier session as list comprehension. So you remember from list comprehension that we can quickly and easily set up lists of things by using the square bracket notation and then saying do this for each element in that, and sometimes we can add in where it meets a certain condition. So here what we want to do is grab, we're trying to calculate the total number who are infected, so we want to grab the infected variable value, which is a Boolean variable that says true or false in each agent. We want to grab that for each agent in our model and put that in a list. So we're going to end up in our list here, which I've got an infection report, with a list of trues and falses, which represent whether each agent is infected or not. So here we're going to say grab agent.infected for each agent in the schedule of agents. So agent.infected is the value we want, and we want to grab that for each agent in the schedule. So remember, the model schedule holds the agents that we've got in the model at any one time. So that will give us a list of trues and falses representing each agent's infected status. Once we've got that, it's really easy. We can just then loop through that list, and if each element says true, for each element, if it says true, then we can increment the total infected counter by 1. That means there's another agent infected. Once we've done that, we can then just return the total infected number, that counter, and that will count how many agents are infected at this particular time in the model. So pause the video now and write out that function. So the next thing we need to do is to set up a data collector, and we want to specify the function we've just written as one of the model reporters, and we can have things called model reporters and agent reporters. Don't worry about the agent reporters for the moment. We're going to use this just work with model reporters here. But we're going to say this is the thing that I'm going to. This is the data. This is the thing that's going to collect the data that I need. So we've just set up how we want to collect the data by calculating the number of infected agents. So at each time step, I want you to run that function basically. So we're going to set up a data collector in the disease model class. We're going to do this in the constructor function of the disease model. So make sure you're in the disease model class, not your agent person agent class. And at the end of the constructor, the init function, insert the following code, and this basically says my data collector, self.datacollector, is a new data collector, and it's got the following model reporters and agent reporters. And we haven't got any agent reporters, we've just got one model reporter. And the model reporter, again, we're using a dictionary format here to say I want a label saying total infected. That label is going to store the number of infected people over time, and the value for that is going to come from this function, calculate number infected. So that the value of that function will then parameterize that total infected label. We also need to tell the model to collect from the data collector at each step, because we want to do this over time. So at each time step in the model, we need to do this. So we can do that in the disease model class's step function. So as well as telling it to step through the schedule, we can then also say, and also run the data collector. So run all the reporters in the data collector. We've only got one here at the moment. So we can add this line of code, self.datacollector.collect, and then the input is itself, the model. That will then tell it to run that data collector at each, and therefore the calculate number of infected function, to parameterize the total infected at each time step. So add those lines of code to the relevant places. So the setting up the data collector at the end of the disease model class constructor, and the self.datacollector.collect self at the end of the disease model class's step function. And pause the video while you do that. So now we've got the model collecting the number of infected people over time. All we need to do now is decide how we're going to output this. Well, it'd be really cool if we had a graph, a dynamic graph that showed the total number of infected people over time, and it gradually sort of updated. So we're going to do that, and it's really easy to do that. So because this is a visualization, we're going to need to go back into the disease server file to do that. So in our disease server file, we're going to need to do three things. First of all, we're going to need to import something called a chart module. So we're going to add this to our list of imports, and this chart module is used for drawing graphs. So we can add that to the end of our list of imports. So if you add that line of code to your list of imports there. Next thing we need to do is to specify the graph. What's it going to look like? And we're going to do that underneath where we specified the grid with grid equals in our server file. Because we said before we had a single visualization, which was the grid. Now we're going to have a second visualization in our server, which is this graph. So we're going to set up this new visualization, and we want to tell it that we want a chart, that we want a label for the data, i.e. what data you can actually be plotting. And remember, that's the total infected. We set that up in the data collector. The color of the line that's going to be used to plot the data, and the name of the data collector that's going to be used to grab that label that we specified. So here you can see total infected graph equals a chart module with these things specified. So the first thing we've got a dictionary format for the label and the color, and then the second argument is a data collector. So pause the video while you do that. And the last thing we need to do is to add the graph to the list of elements we want to draw. So in your server equals modular server bit, remember before we had in square brackets grid, and we said that's a list, but we've only got one thing in there. We just need to add this new graph to the list of things we want to visualize. So we can just add a comma and total infected graph after grid in those square brackets. So if you pause the video while you do that. So now let's run that model again. Again, we need to do that from the disease run file. And if you haven't already, don't forget to reset the kernel. Close down your browser and reset the kernel. So I'm just going to go into the code. I'm going to open up. I've got a separate one stored for this. So if I open this up, and we're going to go into the correct file. Remember, it always has to be run from the run file. It won't work otherwise. So we're going to disease run. If I now run that, we'll open the browser again, exactly as we had before, except this time we've also got a graph. And we can see that we've got a label saying total infected here. So if we now run that model, we see that graph will now plot the total number of infected agents over time. And it does that dynamically as the number increases and decreases. So obviously here it's died out quite quickly. If I were to change that, let's ramp up the values a bit, and then click reset, and you can see now there's a huge number of infected agents over time. So now we come to your first exercise. We're going to take everything you've learned so far and get you to do a little bit of an exercise. This is quite tricky, so I'm going to give you some hints as well. So don't worry too much about this. But I'll talk you through the exercise first. So let's imagine you've now been asked to model the potential impact of immunisation against the disease. And specifically, those who are immunised against the disease will be immune from catching the disease for an average of 20 days, although like the disease duration, that will be exponentially distributed. Immunisation is only effective when administered when the individual is not infected, so you can only have non-infected people being immunised. And every day there's a probability that each non-infected person will be immunised. So I want you to modify your model to capture the impact of immunisation. You should include sliders on your user interface that allow you, as a user, to alter the percentage probability that each non-infected individual is immunised with a default of 5%. So that would mean that on each day, each time step of the model, there'd be a 5% probability that each agent who's not infected will become immunised. And also a slider for the average immunisation duration, which will default to 20 days. Remember, that's only an average, and the actual disease immunisation duration will be randomly sampled from an exponential distribution. We're going to assume that nobody's immunised at the start of the model. I also want you to capture and graph the number of immunised individuals over time, and I'd recommend you do that on the same graph as the number of infected. So we just use the data collector to collect and then plot the number of infected over time. On the same graph, I want you to then add in the number of immunised individuals over time and represent that on your grid in a different colour. It could be whatever colour you like. So I'm going to give you some hints because this is quite tricky. So you're going to need some variables to store the mean immunisation duration and the probability of being immunised, and they're going to need to be passed into all the relevant constructors. So think about that based on how your model's set up. You'll need to define a new agent function, a new function within the person agent that is going to immunise the agent, and that function is going to flag that they're immunised and randomly sample how long they're going to remain immunised. So a bit like infection, but this one's going to say you are now immunised and will randomly sample how long you're going to remain immunised. You're going to need to ensure that agents don't infect immunised agents, so you're going to need to think about your infection function. At each step each time step in the model, agents will need to either have their immunisation duration reduced by a day if they're already immunised, or if they're not already immunised, they should become randomly immunised. So much in the same way as infection. So you're going to need to check whether they continue to be immunised. Reduce it by a day if they're now no longer immunised. You'll need to update that in the same way you did for checking the remaining infection duration. You also need to write a function that will calculate the total number immunised over time and add that function to the data collector. So in the same way we just wrote a function to calculate the total number infected over time, you need to do another function that calculates the total number of immunised over time and also add that to the data collector. And in the server file, you're going to need to add a new line to your graph that will represent the number immunised over time. And also a new colour for the agents who are immunised in the grid. So at the moment we've got little grey agents who are not infected and big red agents who are infected. I want you to add a new visualisation that indicates where agents are immunised. You can choose whatever colour or representation you like. And don't forget to also add your 2 new sliders that will determine the mean immunisation duration and the probability of being immunised. Have a go at this. I'd recommend you spend at least an hour, hour and a half on this. It is, as I say, quite tricky. I'm going to be available on Slack. So if you've got any questions, please ask. Ask on Slack, because then everybody, you'll find a lot of you probably have similar questions and we can answer them together. And then in the next video, we'll go over the solution. But give yourself a good 90 minutes to have a look at this. And as I say, any questions, if you need any help, just give us a shout.